Righto, this time we're looking at the tan function, and obviously you can draw tan like, if I grab a pen, if you can draw tan, put in the asymptotes, minus pi on 2, pi on 2, 3 pi on 2. So we need to draw a tan graph, and if I draw that in there, I could also do that in there. So I need to draw a section where it's 1 to 1. And again, sort of similar to the inverse sine, the most sensible place is sort of around the origin. So I'll rub that part out there. I didn't mean to rub out the x-axis. And you can see to limit it to 1 to 1, we want the domain to be minus pi to pi on 2. But this time, because of the asymptotes, they're going to be round brackets. So our domain is restricted of our original tan function is minus pi on 2 to pi on 2. And if I drew in that tan graph, and on the graph they've drawn, that's this graph here. A lot nicer, a little bit smoother than obviously the one I've done. Now, we're going to reflect that in the line y equals x, and I actually think this is the easiest one because it doesn't sort of keep repeating, and you should be able to see that to reflect that there, this would mean the asymptotes would become pi on 2 and minus pi on 2, and your graph would look something like this, that there. Okay, right, and they've drawn that a lot nicer than I have in blue there. So because theirs is nicer than mine and I'll feel bad, I'm going to rub mine out. Okay, now again, look at the domain and range. So the domain for the tan graph, so the domain was round bracket minus pi on 2 to pi on 2, and the range was reals. So for the inverse graph, switch it round. So the domain will be reals, and I think looking at the graph you can see that it goes on forever. And so the range, as I said, just got to watch the brackets, negative pi on 2 to pi on 2. And they've listed that down here and down here. Now again, this composition, so composition is like composite functions, so you know, like f of g of x. So if you're doing f of g of x, f of x would be tan x and g of x would be tan to the minus 1 of x. So the domain for this will be whatever the domain of the bracket is. So the domain for tan to the minus 1 of x is reals. You see I've got a timer going there, so I will just stop my timer. Okay, it's just something I've got happening. If you really want to know, I've got to turn off the pump for the pool. There you go. All right, do it the other way around. Inverse tan of tan x. Obviously, if you do a tan and then do the inverse tan, we haven't done anything to it, so you've still got x. And the domain will be whatever you've got for tan x. So the domain of tan x, and it's the restricted domain that we're talking about, is minus pi on 2 to pi on 2, and of course they're round brackets. And after we do this one, then we'll do some examples and see how all these things work.